Hello, ladies and gentlemen. We're looking at lesson 8.6 today. Lesson 8.6, whoopsies, is all about us being able to factor quadratic equations. So we have a few things that are going to be very helpful for us. Number one is remember that a quadratic, that's when I have something to the second power. And what we're looking at for just lesson 6 is that we have in the form of an x squared plus a bx plus c. So you can imagine this is going to be something that looks kind of scary to start, but it won't be very hard once we get going through the information. So to solve these problems, it's going to be a good process for us is to set up a t-chart. So we're looking for factors of c. What are two numbers that multiply to make c? And then the factors of c, then they have to add to make the b. So the number in front of the x. So you'll see these letters, an M, a P, M plus B, P equals B. These things are coming from the two binomials of x plus M times an x plus P. So when we were to factor this out, to FOIL this out, we get ourselves an x squared plus a an mx plus a px plus a mp. So we're trying to find out what things add to make the middle but multiply to make the end. So we're looking for that information because that's what happens when we FOIL. So here's our first example. So again, our job, we have a 12 and a 7 for our C and for our B. So we make ourselves a T-chart. What multiplies to make a 12? So what multiplies to make a 12 and what adds to make a 7. So we just go through our list of factors for 12, like 1 and 12. They multiply together to make a 12, but they add to a 13. 2 and 6, they multiply to make a 12, but they add to make an 8. Now for me, because both things here are positive, I see right away that we have a 4 and a 3 because those things multiply to make a 12 and add to make a 7. So what I am going to now do is plug those numbers in to our binomials. So we have an x at the front, an x at the back. They are all plus signs over here, so we're going to have a plus and a plus. And because they're multiplying to make a 12, we're going to have a 4 and a 3. So the factoring process, again, is just us undoing the foiling. So we undid the foiling practice. That's what that is what factoring is. Alright, so this is our answers now. X plus 4 and x plus 3. So let's try another one. Now eventually we get pretty quick at this. We're looking for what multiplies to make a 27 and adds to make a negative 12. Now for me, the whole T-chart thing here, I'm pretty cool with it because we're fast. But when we look at this, we have a negative sign here. If you recall before when we FOILed, if we have a negative sign here, that means that we're going to have two negatives because that's the only way that things can multiply to make a positive but add to make something that is negative. So we're going to have an x minus something and an x minus another something. So things that multiply to make a 27. Well, I always go to 9 and 3. That's the most common thing. But how does a 9 and a 3 add to make a negative 12? Well, they both have to be negative. So we're going to have an x minus 3 and an x minus 9. Now, does it matter what order the 3 or the 9 are in? No, not at all. Because I could have an x minus 9 and an x minus 3. I'm still going to multiply. And as we know from our properties, it doesn't matter which order that you multiply in because you're still going to get the same answer. All right, so folks, that's factoring. Let's try another one here. And we're going to do it without the table this time. I'm just looking to find what two numbers multiply to make a negative 18 and add to make a 3. Oh, never mind. We're going to make the table. Multiply to make a negative and add to make a 3. So for us to get a multiplying to make a negative number, we know that we're going to have one of them is going to be a plus and one of them is going to be a minus. That's the only way in my foiling where I do the last times the last where I get a negative. So when we undo that, we know that because this is negative that one of them has to be a negative and one of them has to be positive. Alright, so things that multiply to make an 18. 6 and 3 and this one would have to be a positive, this one has to be a negative to make this add to be a 3, right? So that means the 6 is positive, the negative is 3, and again, it doesn't matter which order we put these in as long as the 6 is positive and the 3 is negative. All right, our next example is your job to try on your own. Same process, make up the table and then fill in your two binomials. Now, if we are expected to solve the problem, things get a little bit different. Now remember in the very first slide here, I guess, we had an x squared plus a bx plus a c equals to 0. So step number 1 is to make these equal to 0. So when I make that equal to 0, I'm going to have to subtract 15 from both sides of that equal sign. So that becomes an x squared plus a 2x minus a 15 equals 0. Now folks, this is the cool part. We're again looking to get something that multiplies to make a negative 15 and adds to make a positive 2. So those numbers are a negative 5, a positive 5 and a negative 3. Now this stuff equals to 0. Now this is the part that's most important for us. When we are solving these quadratic problems, it's for us to understand that if this number times this number equals to 0, what that means is that one of the numbers has to be equal to 0. So an x plus 5 or an x minus 3 has to equal to 0, which means that one of them is or both of them are. So what we do is we set each individual binomial equal to 0, and then we solve both of those equations, which means that x minus 5 minus 5, x equals to a negative 5 for this side, and for this equation plus 3, x is equal to a positive 3. Now there's two answers to these because they are a quadratic problem, which means that their graph makes a U-shape. So the two answers are where they cross the x-axis. That's where it says x equals negative 5 and x equals a positive 3. So you're going to have to get your specific answers for question number 2 here. And that's what we're looking for you guys to be able to do when we are factoring from lesson 8.6 today. So again, that was the zero product property. If two numbers are multiplied together and they equal 0, that means at least one of them, possibly two of them, are going to be both equal to 0. So we set both equations equal to 0. Good luck, and this is Burmination signing off.